Topic 12, the logic of statistical inference. We're finally moving. We have been working with probability quite a bit, so we're still going to be using those tools that we learned, but now we're moving more into the statistics side. We're going to start with an example, 12.1. And the question, research question is, can chimpanzees solve problems? So that's what we're interested in. Now, in this case in particular, we're going to look at a specific chimp. So in 1978, there was a study done and it was published in Science magazine, which is very well respected. We can assume it was a well-designed study. Reported an experiment where an adult chimpanzee named Sarah was shown videotapes of 8 different scenarios of a human being faced with a problem. After each videotape was shown, she was presented with 2 photographs, one of which depicted a possible solution. So here it's a little hard to see, but I'll blow it up. In one videotape, she was shown a human unable to hear any sound coming out of a boombox. So that is a boombox in here. It's a little hard to see. Just get my... And it is unplugged. So no sounds coming out. Of the 2 photographs shown to her, one was a picture of an electric plug and a power outlet. So here it is plugged in now, or a plug plugged in. The other was of a picture of a man climbing a ladder. Out of those 8 problems that Sarah was presented with, she picked the photograph correct 7 times. So that's pretty amazing. Before we start looking at the statistical part of it, let's go back, and this is a review from what we've been doing along the way. What is the observation unit, variable and type, and the statistic? We're going to start there. I suggest pausing the video, even just for a moment, and see if you can come up with these, think about what they are. I'm going to give you a hint. The observational unit is not each Sarah. Okay, so observational unit, we know is each something. We're going to look, and a lot of times students struggle to get this. So I say skip this for the moment. Think about what's the variable and type. Well, what's varying? Whether she gets what? The correct photo or not? Whether she picks the correct photo? That, of course, is going to be categorical and binary. So what are we looking at? We're not looking at each chimpanzee. We're looking either at each videotape, and you're like, well, videotape doesn't really make sense to me because those don't seem really related to the variable. You could also say each video or each problem scenario. So she's looking at different problems and then she sees if she can effectively solve it. In other words, pick the correct photo. The big thing is it's not each chimpanzee, it's not each Sarah. The statistic is p hat. So there's the symbol. And this is the proportion correct out of the sample of 8 questions. And we want to be careful here with statistic in particular that we refer back to the sample. So it's p hat, once again, which is, we found that she got 7 out of 8 correct. That equals 0.875. And that is the proportion out of the sample of 8 questions. Proportion correct, excuse me, out of the sample of 8 questions. Now, what's the parameter? Remember, parameter describes the population. So that's going to be just P, and that's the proportion. So I'm going to do prop with a period there for proportion. Correct out of all such problems. Do we know that P, that true proportion? And the answer is no, or we wouldn't be doing a study. So the numeric value is unknown. Now, assuming that the study was well designed, what are 2 possible explanations for Sarah getting 7 out of 8 correct? Well, what's one explanation? If you think about it, could she just be guessing and got lucky? Sure. She's choosing randomly, and she got lucky. She got lucky on 7 questions. Okay. The other option is that maybe she really can solve. She knew what she was doing and was choosing correctly. So she can solve, and there we go. She actually knows what she's doing. Now, these two explanations translate into hypotheses. The null hypothesis, this is number one here, is called H naught. It's not H sub zero, it's H naught. Sarah is randomly choosing between the two photos. That's what she's doing. She's just randomly choosing and just got lucky on 7 of them. Now, the alternate hypothesis, which is usually the research hypothesis, is H sub A. Sarah tends to choose the correct photo more often than the incorrect photo. So she actually is not just guessing, she's actually solving. Now, you're going to notice that these two never overlap. Okay, the null and the alternate hypothesis does not overlap ever. So definition, the hypotheses are statements about the general process, in this example, choosing an answer for each question, not about the observed data. You would start with the hypotheses before you would actually do any testing. The null hypothesis is also, think of it as the dull hypothesis. In other words, nothing is going on, or all outcomes are due to random chance alone hypothesis. Now, the alternate hypothesis contradicts the null and is generally considered the research hypothesis. It is the something other than random chance alone is at play. Thus, the hypotheses are always about the parameters of interest. Okay, so we're looking at parameters. We're not looking at the statistics. We're looking at parameters. So once again, this is not about the statistics or the sample. We're really interested in what's going on in the population. In this case, P being for the proportion. We know P hat, we don't know P. So let's state the hypotheses in symbols. The null and the alternate. The null is H sub naught, and the alternate is H sub, I'll show a capital A. A lot of times it's easier to see. Now, she has 2 options. If she was just guessing and there are only 2 options, what if she's just guessing, what would we expect the proportion to be? And hopefully you think, well, 0.5, 2 options like heads or tails, 50-50. Now, if she is doing better than guessing, would you expect my sign to be less than, greater than, or not equal? And hopefully you think, well, oh, she's doing better. It's going to be bigger than 0.5. Now, remember, these two cannot overlap. All right, so you would never have a equal here and a greater than or equal to here, or less than or equal to. Okay, so just be careful with that. Is it possible, even if Sarah is just randomly choosing between 2 photos, for her to get 7 correct out of 8 just by chance? Sure, of course it's possible. Do you think it would be surprising? Well, yeah, I'd be surprised if she's just randomly choosing that she gets 7 out of 8 correct just by chance. Now, how would you convince a skeptic that if Sarah is just randomly choosing between 2 photos, it would be unusual for her to get 7 out of 8 just by chance? Well, we could look at the probability of that happening. But to show a skeptic, sometimes it's also, I mean, you can show them the numbers, strictly the numbers, but sometimes it's good to show them in other ways, like by, I don't know, flipping a coin. We want to show a skeptic what results from randomly choosing, from there being random choosing on 8 problems, and what it looks like compared to Sarah's 7 out of 8 that she got correct. Note, we need to model what the long run pattern, because remember, probabilities are about long run, of Sarah's score would have looked like if Sarah was just guessing which photo to pick. We're going to use coin tosses to simulate the random process of this just guessing. I would try hands-on first to convince the skeptic, and that's what we'll do next.